Thank you to the International Magnesium Association for presenting Luxfer Technologies with the 2022 Environmental Responsibility Award. This is given to L&T for our work on reduction of CO2 equivalent emissions from our magnesium casting processes. I'm Matthew Murphy, Head of Magnesium R&D at Luxfer Technologies, and I'm going to talk you through the work carried out. Luxfer Technologies, a subsidiary of the Luxfer Group, is a materials technology business specialising in the design, manufacture and supply of high-performance magnesium alloys and zirconium oxides to our customers in diverse markets including aerospace, defence, automotive and medical. There is a lot of debate within the scientific community and increasingly with society as a whole that a human-induced climate change is occurring. It is everybody's responsibility to look to reduce our carbon footprints, and Luxfer is no exception. The Luxfer Group have committed to a group-wide target of a 20% reduction in CO2 equivalent emissions by 2025, and this work is just one aspect of Luxfer's plans to reduce our business's carbon footprint. Luxfer Technologies made huge strides over the last 20 years, as you can see in the top graph. However, further progress has stalled in the last 5 to 10 years, and so the team has sought to reinvigorate this programme. This required a committed team with improved technological know-how and capabilities. The first step towards reducing our CO2 footprint was to identify the source of emissions. By reviewing previous years, we identified the best approach to the challenges we face. As can be seen on the top right hand graph, the primary source of emissions comes from legacy SF6 usage. The secondary source of emissions comes from R134A usage, which was originally implemented to replace SF6. The second stage towards reducing our CO2 footprint is to identify the source of those emissions within the plant. By looking at the combination of volumes and process parameters, we can identify which processes are generating the highest level of emissions. At Luxfer Technologies, we make numerous products from a wide range of processes. Each process was evaluated, risk assessed from a technical feasibility standpoint, and a plan set out for achieving a CO2 reduction within that process. These were then prioritised into two stages, a stage 1 and a stage 2. Within stage 1, a significant progress will be made, but only by realising both stages will we feel we've truly done enough to reduce our footprint. In order to achieve these reductions, clearly challenges had to be addressed, otherwise we would have made these changes many years ago. The next two slides discuss some of the technological considerations in this project. As stated earlier, a significant portion of our emissions come from cover gases, SF6 and R134A. Luxfer Technologies use a large number of open casting processes, which limits the options for alternatives. Initial evaluation with Novex 612, which has a global warming potential of approximately 1, showed that the product would be suitable for some of our processes, and a $500,000 investment was made in the mixer and supporting infrastructure. Within the project, we set out 3 rules. We will remove remaining use of SF6 from the Manchester facility, we would minimise the use of R134A, and we would introduce and maximise the use of Novex 612. Recognising that Novex 612 probably would not work for all our processes, we also ensured that all our processes were optimised with minimal use of R134A. Given the complexity of the process carried at Luxfer, design equipment that would enable cover gases such as Novex 612 to be used was challenging. Intensive use of 3D CAD and process simulation enabled the team to prototype and predict effectiveness and therefore accelerate the transition. The building's capability and in-house skills has and will enable unique approaches to each process and minimise our carbon footprint going forwards. So on to the important question, what have we actually achieved? Based on usage measurements throughout 2022 to date, we're on course to achieve a 66% reduction in CO2 equivalent emissions in 2022 versus the average over the prior 9 years. Importantly, this can also be seen in our site CO2 equivalent emissions per tonne of product sold, demonstrating this is a true reduction in the carbon footprint of our products. Going into 2023, with further improvements taking place, we're currently forecasting that we will be able to reduce these figures again by 55% compared to 2022. Overall, a very positive result. It's been a presentation on how Luxfer Technologies has reduced its CO2 equivalent footprint, and I thank you for your time. Once again, we thank the International Magnesium Association for this award.